Hello friends, welcome to Learner's Forum. So in this video, we will see about the topic complement and we will solve the required problems and along with which we can see the shortcut also. So in general, we have complement as two types. One is R's complement and the other is R minus 1's complement. So where R refers to the radix value. Radix in the sense it is base. R minus 1 in the sense we have to subtract 1 from the base value. Since it is getting reduced, we can call it as diminished radix also, which means there is a reduction in base value. Now let us solve a problem. The question is find the complement of 7 which is given with the base value as 10, which is nothing but the decimal number. So the base value is 10 and the given number is 7, which means 10 minus 7 is 3. So we have to reduce the value from the given base. So in general form it is represented, that is R's complement is equal to R power n minus n, where R refers to base value, small n refers to the total number of digits, and the capital N refers to the given number. So we have to make sure that we understand what is capital N and what is small n. Small n is total number of digits, whereas capital N is the given actual number. So this is the formula for calculating R's complement. So given is 10, so 10 power n value is 1 and capital N is nothing but the given number, so it is 7. So 10 power 1 minus 7, 10 power 1 is 10 minus 7, which is 3. So this is the answer for the given question. Find the 2's complement of given binary number 1101 to the base 2. So to solve this particular value, we can use the same formula, which is R power n minus n. R is base 2, so 2 power small n, which is the total number of digits, we have around 4 bits, so it is 4 minus capital N is the given number, which is 1101. So here 2 power 4 will be 16 minus 1101. So here we have one value in decimal and one value in binary. So we have to convert either decimal to binary or convert binary to the decimal value. So 1101 can be converted towards equivalent decimal using this 8421 technique, which is 8 plus 4 12, 12 plus 1 is 13. Now we have 16 minus 13, which is equal to 3 to the base 10. So this is the 2's complement for the given number. So 3 to the base 10 can be represented in binary as using the same 8421 technique, since we have only 3. So 2 plus 1 will be 3. So 011 will be the binary value. So this is how we have to calculate. Now let us solve one more example. Determine the 10's complement of 5690 to the base 10. So this is also belonging to R's complement. So R is equal to 10, n, which is number of bits, 5690. So we have 4 bits. So n is equal to 4 and capital N is equal to 5690. So we have obtained the values for R, capital N and small n. Now let us use it in the formula R power n minus n, which is equal to R, which is 10. So 10 power n value is 4 minus capital N, which is 5690. So 10 power 4 is 10000 minus 5, 6, 9 and 0. Now we have to subtract the value to get the value 4310 to the base 10. So this is the 10's complement for the given number 5690 to the base 10. So till now we have seen the R's complement. Now let us see the diminished radix, which is R minus 1's complement. Now let us see the difference between R's complement and R minus 1's complement. So here we have considered for the 4 types of number system: binary, octal, decimal and hexadecimal, which means taking the R's complement will be the same value for base, that is 2 for binary, 8 for octal, 10 for binary, 10 for decimal and 16 for hexadecimal. When it comes to r minus 1's complement, we have to subtract 1 from the actual base value. So 2 minus 1 will be 1 for r minus 1's complement. So we have got 1. Similarly, 7, 9 and f. So now let us see the relation between r's complement and r minus 1's complement. So r's complement will be equal to, as per the formula, it is r power n minus n. R minus 1's complement, to calculate this, we can replace the value of r as r minus 1 now. So r minus 1's complement will be equivalent to, in the entire formula, replace r for r minus 1. So r power n minus 1. In this, r power n minus 1 is r's complement, so we can replace that. Adding plus 1 on both sides, we can get it as r minus 1's complement plus 1 is equal to, plus 1 and minus 1 will get cancelled, the remaining will be r's complement. So the relation will be r's complement is equal to r minus 1's complement plus 1. So this is the relation between r's complement and r minus 1's complement. So for r minus 1, we will not have any borrow, and for r's complement, we will have borrow. So this is the relation between r minus 1's complement and r's complement. Now let us solve example for r minus 1's complement so we can get it better. Let's find the 7's complement of 6630. 7, in the sense it is reduced from 8, so it is r minus 1's complement. We will solve it by two methods. One is formula method, one is the shortcut method. So as per the formula, r minus 1's complement will be r power n minus 1. 7's complement, which is 8 minus 1. So r minus 1's complement has to be found here. So we can get the value of r, n and small n using the formula method. So r power n minus 1. The base value r, capital N, small n has to be understood. So r is 8 here, which is octal number. So 8 power, small n is number of digits. So 6630, in the sense we have 4 digits. So small n is equal to 4, and capital N is the actual number, which is 6630. So that is written here to the base 8 minus 1. So 8 power 4 is 4096, which is a decimal value, to the base 10 minus 6630 to the base 8 minus 1. Now we have to make either octal to biodecimal or convert this decimal into octal. So we can convert this decimal into octal first. So 4096 will have the equivalent octal value as 1 followed by 4 zeros. So we have seen the conversion and all in our earlier topics. Minus 6630 minus 1. Now let us perform the octal subtraction, which will get the answer as 1147 to the base 8. So the 7's complement for the given number is 1147. So this is the formula method. We can use it for semester, but for competitive exam we can apply some shortcut so that we can save time. So the shortcut is, we have to take the complement number. That is, the question asked is, find the 7's complement. So we have to take this number 7 and we have to look in for the given number, which is 6630, which has 4 digits. So we have to take 7 with 4 digits of the same number, that is 7 followed by 4 digits. So since n is equal to 4, we have to take 4 number of 7's. So take it as 7, 7, 7 and 7, and subtract the given number, which is 6630. So if you perform subtraction now, we can get the same answer, which is 1147, similar to the formula method. So whatever be the value of r minus 1, we have to use it in the shortcut this way. So this is the procedure. As you can see, the formula is taking time, and for shortcut method we have got the answer in a single step. We have a small note here. So to find the r minus 1's complement when n is equal to 4 for given number, if we consider for the base value as 10, that is for decimal type, r minus 1's complement will be 10 minus 1, which is 9. And since the value is 4, as per the shortcut formula, we have to replace with 4 9 values. So 4 nines is written minus the given number. 8 minus 1 will be 7, and since n is equal to 4, we have got 4 sevens. For n is equal to, for r is equal to 2 and for r is equal to 16, we have got the similar values. We have to replace with the given number. We have assumed that the given n value has got 4 digits. So that is the representation here. So after filling out the given number, we can perform this r minus 1's complement using this shortcut. Now let us solve one example to understand this concept even more better. So the first example is find 1's complement of 1101 and also find its 2's complement. So first we have to perform the r minus 1's complement and then we can calculate this 2's complement. So 1's complement of 1101 is to be calculated first, from which we have to calculate the 2's complement. So r minus 1's complement will have the formula. The base value is 2 here. So 2 minus 1 will be 1. And since we have 4 digits, we can take 4 ones. Since n is equal to 4 and the base value is 2, 2 minus 1 will be 1 and we have to take 1 for 4 digits. So 4 ones to the base 2 minus the actual number, which is 1101. So after performing subtraction for the given two numbers, we can get the value. So 4 ones to the base 2 and 1101 is taken here. We have to perform binary subtraction. So all these things we have discussed earlier. Now let us perform the subtraction. 1 minus 1 0, 1 minus 0 1, 1 minus 1 0, 1 minus 1 0. So 0 0 1 0 to the base 2 will be the 1's complement, which is the first part of our question. So r minus 1's complement is done here. Next, from r minus 1's complement, we can calculate the 2's complement as per the relation which is given. So r minus 1's complement plus 1 will be the value for r's complement, which is our relation. So we have got the r minus 1's complement value. We have to add 1 to the answer. So plus 1 means we will get the result as 0 0 1 1, which is the 2's complement, that is the r's complement. So this is the formula or the relation between r minus 1's complement and r's complement. So with using the value of r minus 1's complement, we can calculate this r's complement also using this technique. So we can use a shortcut to find the answer, which is apply 1's complement. So we will get 0 0 1 0, that is 1 1 0 1 is our actual bit. Replace 0 with 1 and 1 with 0, so we will get 0 0 1 0. So 0 0 1 0 will be the answer for 1's complement, which we have got like here 0 0 1 0. Next, to get the 2's complement, just add 1 to the last bit. So we will get 0 0 1 1, which is the answer 2's complement. So for competitive exam, we can use the shortcut in this way. Let us solve one more example. Find 1's complement and 2's complement of 11010. So the shortcut is, for 1's complement, we have to replace 0 with 1 and 1 with 0. And to calculate 2's complement, we have to add 1 to LSB of 1's complement. So let us find the 1's complement first. So the given number is 11010. So replace 0 with 1 and 1 with 0. So it will be 0 0 1 0 1. So we have got the answer for 1's complement. So to get the 2's complement, 1 to the last bit. So 1 plus 1 is 0. Remainder 1 1 0 0. So 0 0 1 1 0 will be the 2's complement answer. Let us solve one more example. So from LSB, copy all the zeros till first one. This is to find the direct 2's complement. So starting from the last bit, we have to copy all the zeros. Till the first one, we have to repeat the same procedure. So given is 1 0 1 1 0 1 0 0. So starting from the least most bit, copy all the zeros. So 0 and again we have 0, so we can copy it as such. The first one we have got it here, so copy it as such, and the remaining value we have to take a complement and copy the remaining value, replacing 0 with 1 and 1 with 0. So here it will be 1, remaining 0, 0, 0, 1 and 0. So this is the way to get the direct 2's complement answer. So we can use this shortcut when asked for to calculate the direct 2's complement instead of 1's complement and then 2's complement. So we can check it with the previous shortcut that we have used here. So 1's complement for the given number will be 0, 1, 0, 0, 0, 1, 0, 1 and 1. So we have to add 1 to the last bit. So adding 1, we will get 1 plus 1 is 0, remainder 1, again 1 plus 1 is 0, remainder 1. So 1, 1, 0, 0, 0, 1 and 0. So we have got the same answer like the second shortcut also. This is the procedure to calculate 2's complement using these two different shortcuts.